Hello. In the last video, I have explained you what are the steps need to be taken for implementing the SVM machine learning model. So, first step is by extract data. Let's do that. So, initial step is to extract the data by importing the pandas package, which helps in reading the data from the CSV files or Excel files as PD. Data is equals to PD dot read CSV double quotes. Within this code I will paste the file path, and before that make sure that you have to give this here a backslash or opposite slash to consider the slash so that it can read. If I read this is my data frame, position, level, salary. So in the explanatory data analysis I have to check whether does it contains null values or not. For that, data dot is null dot sum. It will give how many null values are there. So currently it is 0 for all columns, means the data frame it doesn't contain any null values. Let's proceed with the information. What the information does it contains? Data dot info. Next, data dot describe. So it gives me the description of the data frame for each column, level and salary. And now, as we know, in the information, if it is an object, we have to convert into integer or float. So for that, the feature extraction, I will initial change that one from sklearn dot preprocessing import standard scalar and label encoder. LE is equals to SC is equals to standard scalar X is equals to. So before X, we have to add one more thing, is X equals to data dot ilog includes all the rows starting from 1 to -1 till the values, and in the y also data dot ilog all the rows for last column and convert it to values numpy array. If you check that, print x is print y. So for each one, I have converted into 1 to 10 and its respective salaries. X equals to sc dot fit transfer of x, and y is equals to sc dot fit transform for y dot reshape, where the number of rows will be number of length of the one, the y and 1. So I'm converting it. Then now I have to build a model. I have to train. I have to split once the data from scale dot model selection import train test split x train, comma x test, comma y train, comma y test, where my values will come from this function where I pass x and y. So when I pass this test size 0.2, which means, or 0.3, which means this train test split function returns the four values x train, x test, y train, y test, where I am passing the parameters x and y and test size, which tells that to split this x and y data frame into 20% of data is test and remaining 80% will be for the training. If I check the shape of x train, x underscore train dot shape, in the same way I will copy this entire line for checking the shape of the y train also, and for same thing for the test size as well, x test and y test, x test, y test. Where in this, okay, so there are total 10. If you see here there are total 10. After splitting the data, the 70-80% of the data is for training set and 20% data for the test set. If I change this to 3, then 7 is to 3. Okay, so for now I am taking as 2. Okay, so after this, after the splitting the data, you have to apply the model from sklearn dot for SVM. In the sklearn there is an SVM package, in that the model name SVC and SVR. Within these two, this is the for the classification, SVR for a regression. As we are talking about the regression model, I am considering SVR. Now my model is equals to, I have to initialize this SVR and model dot fit x train and y train. And I have to mention also that kernel should be RT or linear. If I run this, done. And we can also remove this warnings with importing warnings and warnings dot filter warnings with passing the value ignore. Now after fitting this, let's go start with the model evaluation. For the model evaluation, I will consider metrics from sklearn. Sklearn dot metrics import R2 score, mean absolute error, squared error, import numpy s and t. I will find the test accuracy. Test accuracy equals to model dot score. I will pass x test and y test. X test and y test. Train score, model dot score. I will pass the values. I will pass the dataset x train and y train. Print testing score is score, and print train score is train score. Parenthesis, I found that 57% and 70% for testing score and training score respectively. Now I will find R2 score. R2s variable which stores the R2 score, but before this I have to find the I have to predict the value. For that I will use ypred is equals to model dot predict, and I will pass the value x test print ypred. For run this I found two predicted values. So R2 score is my y test. I will find the R2 score for y test across the y predict. In the same way, for the mean absolute error also, I will pass y test against the y predict. Mean square error also, I will pass y test, y pred for the root mean square np dot square root of mean square error. Now I will print those values. Print R2 score is R2s. Print MAE mean absolute error. MAE print square mean squared error. MSC is MSC print root mean square error. RMSC. I will give RMSE. Okay, so I have to give comma. If I run this, I found these are the root mean square, R2 score, mean square, and absolute error. And now we have to analyze the results. For that, I will import matplot. I will to change it to Python so that I can colored dot pyplot as plt. So I have to plot for sc dot inverse transform of x, comma sc dot inverse transform of model dot predict for np dot array of x dot reshape -1 comma 1, where I will tell to color. I have to color is red, red, and plot same for scatter for sc dot inverse transform of x, comma sc dot inverse transform of y. And for this my color will be c is equals to plt dot show. If I run this, it is asking for that today something happened here. So np.array. I'm passing the x. Let's check the plot xvc predict model dot predict. So I will copy this. Let's see what will happen. Nice. So there was just some mistake. So this is what I'm getting. So what is happening? I'm plotting the graph line graph for inverse transform of x and inverse transform of predicted value of x by reshaping it to 1D as 2D. Sorry, it is converting into 2D and plotting with the red line. This is my red line. So this is my predicted graph, and I'm using the scatter plot between the inverse transform of x and y. So I'm not using the training set and test set. I'm passing entire data set x and entire data set y and plotting it. So this is blue lines are my actual one. This is my predicted one. This is how I'm plotting. So these are the steps to build an SVR. If I'm saying that find, I want to apply the SVM for the linear, linear model applied. Now I will test see the test accuracy in the further linear. Okay, it's coming less than 1. So this is my linear. If you see here, it is my linearity straight line. If you want to find the further kernel RPF, then don't use linear, use RPF. Done, 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 done. And if I run this, now the linearity will be not there. It will be the curved line. This is a curved line. So this is the difference between the linear and RPF for SVR. So using the kernel, we can initialize whether the SVR is for linearity or not, or continuous values. This is how you can implement the SVM in regression. So in the next video, I will try to implement much more examples. And if you have any doubts, let me know. Thank you.